So let's see orthogonality of vectors. Let's say we have vectors v1, v2 belonging to a vector space V. So is orthogonal if the inner product or dot product is 0, right? So this can be given as v1 transpose into v2 equal to 0. And from this, a set of vector is said to be orthonormal if apart from being orthogonal, each vector is of unit length. So being orthogonal is simply being perpendicular, right? And being perpendicular, we know that a dot product of two vectors a and b will be 0 if they are perpendicular. The magnitude of a into the magnitude of b into cos theta, theta becomes 90 and cos theta becomes 0. So similarly, if we have two vectors, then the transpose of the first vector multiplied with the second vector will give you the 0, which is nothing but the dot product, right? So if it is orthogonal, the dot product is going to be 0. And then from this set comes the orthonormal. A set is orthonormal if apart from being orthogonal, that is apart from being perpendicular, each of the vector is of unit length. Then we can say that the set is orthonormal. Let's say, for example, for three-dimensional space, v1 equal to 1 0 0, v2 equal to 0 1 0, and v3 equal to 0 0 1. So these three vectors form orthogonal set and also orthonormal, because these three vectors are of unit length, of course, and they are perpendicular to each other. This is to the x-axis, to the y-axis, to the z-axis, because this is a three-dimensional xyz plane, xyz space, right? Now a point of conclusion here is, if n such vectors like v1, v2 and so on, vn, in the vector space Rn space are orthogonal, then they are surely linearly independent and span the vector space. Let's say if this Vn Rn was vector space V, so span the vector space V and form a basis for Rn vector space.